Oh, I can start now? Yeah. Okay. Good afternoon, everyone. Welcome to my workshop. I'm Yue Chen. I also go by Tracy. Today, I'm going to talk about building web applications with large language models. So first, about me. I'm a computer science PhD student at UMD, and I'm also a member of Human Data Interaction Group, and we belong to a larger group which is called Human Computer Interaction Lab. And we're doing pretty interesting projects about human-computer interaction. So if you're interested, feel free to check our website. There might be some openings for undergrad researchers. So agenda for today. First, I want to go through the basics of large language models and front-end development. And then I'm going to share 2 examples of web applications powered by large language models. The first one is to display ChatGPT's answers. So it's like recreate your own ChatGPT. And the second one is to simulate conversations among multiple AI agents. And then I will talk about the environment setup and additional resources in case you are interested. So first, what are large language models? Since you are hackers, I assume you all have heard about this term. So it has several aspects. First one is large and general purpose. So it's trained on a very large size of data set and a lot of model parameters. So for like ChatGPT, it's almost trained on the entire knowledge on the web, and it has billions of parameters. And such models are not for a single purpose. It can solve a lot of common tasks. For example, summarize a paragraph of text and answer questions. And a lot of models are pre-trained and fine-tuned. So what does those 2 words mean? Here, I want to make an analogy with dog training. So suppose you got a dog and you can teach the dog some basic instructions like sit and come. So this is called pre-training. And after that, if you want to turn your dog into a specialized dog, like a police dog, hunting dog, then you need to provide some special training. And similarly to large language models, if you want it to be very good at solving a domain-specific problem, like medical problems, legal problems, then you also need to prepare this domain-specific data set and do some fine-tuning. So here I want to remind you that ChatGPT is only one of the large language models. There are a lot of companies and organizations. They race to develop their own large language models. And here you can see like Google and Anthropic and like Microsoft, Hugging Face, Meta. So currently GPT-4 might be the state of the art, but in the future, the landscape could change. Okay, so I also want to talk a little bit about front end. There is like 1 or 2 front end courses at UMD. So how many of you have taken that? Please raise your hands. Okay, 1. Okay, yeah, so what is front end? The front end of a website is a part that users interact with. So it includes everything that a user sees. And a basic front-end framework involves HTML, CSS, and JavaScript. Since most of you have not taken front-end classes, here I want to show you an example. So this is a technical website, and everything I see belongs to the front end. And here I can do something pretty cool. If I right-click, click Inspect, and I hover on that, I can see the size of the image. I can see like the font size. I can even change the text on my side. I mean, it's not on the server. So if I select the text and find the paragraph, it says Technica is the world's largest hackathon. And I can even edit that. So I can change this to Galaxy. Okay, and now on the website, you can see that the change has been reflected. I can also play with the colors. And however, those changes are not saved. It's like a playground. And if I refresh, then it will go back to the world's largest hackathon. So Frontend is pretty fun, and I suggest you taking a course in this. But it does not matter if you don't know Frontend. Here, I will introduce these fun parts of our projects. So what are we going to build? As I mentioned, we're going to build 2 projects. One is to build your own ChatGPT, and the other is to simulate conversations among AI agents. So if you have watched some science fictions like Westworld, it's like those hosts. Okay, so here is the website. The first one, it prints out a question. So name a turtle stands in front of the library. And the blue text is ChatGPT's answer. It says Shelly the turtle. And if you refresh that, okay, now it returns a different answer. It's called Sheldon, the bookworm turtle. So I think that's the fun part of large language models because it's not deterministic. So every time you refresh, you can see some different things. And the second part, I created 2 AI agents, and they are called Alice and Bob. Let's see if I can enlarge this. So I give them some memories. Alice lives in College Park, and she has her favorite restaurants. And she also remembers some facts about those restaurants, like one of the restaurant Light was closed last year, and she ate at Hanami yesterday, so she wants to try something else. She also remembers she will have lunch with Bob today, and currently Alice, the agent, is hungry. And similarly, Bob is another AI agent. He also lives in Maryland, and he has his own favorite restaurants, and he's a vegetarian, and yesterday he ate at Sweet Green, and he also wants to try something different. So I think this will take a longer time. So currently it's this running, but I have taken screenshots of previous conversations like this. Okay, so for the first one, ChatGPT has returned different answers for the turtle in front of the library. Here I choose 3 examples. And for the second one, so here I highlight the constraints. Why do I want to introduce constraints? Because I want to make sure those AI agents are intelligent. They will not visit a restaurant that was closed last year, and they will also not visit the restaurant that they just visited. So here, those are constraints. Volad was closed, ate at Hanami yesterday, and Bob is a vegetarian and ate at Sweet Green yesterday. Okay, so here is an example. So Alice said, where should we have lunch? How about Sweet Green? And Bob said, I recently ate at Sweet Green, so I was hoping we could try something different. So I think Bob here passed the test because he remembered he ate at Sweet Green. So Bob suggests 2 restaurants. And then they have more conversations. And in this turn of conversations, they reached an agreement that they are going to Potomac Pizza. And in the second round, again, Alice suggested going to Sweet Green, and Bob rejected that. And then after some discussion, they decided to go to Board and Brew. And here we can also introduce the third AI agent, which is the host. So the host asks Alice, like, after the discussion, where do you and Bob decide to have lunch? And it seems Alice does not remember the conversation. So she just asks, do you have any suggestions? And this time, it seems Bob remembered the conversation. And Bob said, yeah, I think we decided on trying out this new place called Board and Brew. So you can see that ChatGPT is not perfect, and sometimes it makes mistakes. So do not trust its answer all the time. Okay, so how can we set up the environment? Here I listed several libraries and frameworks that we're going to use in this tutorial. However, I think each of those libraries and framework has a steep learning curve, and I do not expect people to learn that in 20 minutes. So I have a GitHub repo, and you can just go to my repo and clone that. So, or if you really want to create, from scratch, here I have some command lines. Okay, so suppose we have the repo ready here, and then we install all those packages. So the first thing is that we need to have access to ChatGPT. So perhaps you have tried the chatbot mode. So you just type something and click submit button, and then it returns an answer. But if you want to build that feature in your own web application, you need to use API. I think there might be a tutorial on API during this hackathon. Anyways, so you need to go to the OpenAI API website and then create a new secret key. And then you want to save that secret key on your folder. And please never ever commit your secret key to any GitHub repo, because that will have safety issues. But here is just for local test. So I just include my key here. And after you have the API key, let's go to the code explanation. So for the first one, we just want ChatGPT to return an answer for turtle name. So here I create a file. It's called turtle.tsx. So the suffix is for TypeScript. It's similar to JavaScript, but it's just more typed. So here there are only a few lines. First, we need to import the library, which is OpenAI. And then here is our turtle function. And turtle function will take two input. One is prompt, and another is API key. And because it takes some time to call the API key and get the answer back, so it has to be asynchronous, which means we need to wait for the function. So here, I added the identifier async, which means asynchronous, and also await. So we are going to wait until the answer comes back and then return the results. So this might be different from what you've met in other programming languages like Python, because things just happen instantly. But in front-end development, especially if you are going to call some API, you often need to wait for a few seconds and until the answer comes back, and then you can return. Okay, so here is the turtle function, and we export this function. So we can call the function in another file. And where did we call that? We call it in a file called app. So it has a lot of code, but let's just focus on turtle. So here, I call the turtle. So I created another function called turtle namer. And here I use the try catch in case there is any error, because I'm calling an API and a lot of things could go wrong. Perhaps my key expired, or perhaps the timeout. So I want to print out the error. And here we use the variable turtle name to store the returned response from turtle. And then we want to display that on the web page. So how can we do that? Here I print it out on the web. So first we print out the prompt, and then we print out turtle name. And because we want to differentiate the font color between the prompt and the answer, I give the answer a class name. So I can add some styling. And how does that work? So if I go here, I can go to the styling part. So the styling is handled by CSS. And that's why you can see a very colorful Technica, because they have all kinds of styling. And here is the answer. So if a text belongs to the answer, then the font size is like 14 pixels and the color will be blue instead of black. And I also add some alignment. Okay, so this is about turtle. And let's go over the other example. It's more complicated. It's the agent. Okay. Okay, so now here is the agent, and we need to import these necessary libraries like generative agent memory, so we can manage agents' memories. And also we need to create some memories for our agents. So here I store them in constants. As I just showed on the slide, I have some memories assigned to Alice. So this part is the fun part. You can just play with it and assign any memories you want. So here I assign like where does Alice live and what she has eaten and what she remembers. And again, similarly, Bob's memory. Okay, so after we import those memories, we need to do some logistics, like again, create another OpenAI object. Here I use GPT-3.5, which is ChatGPT. And here is a memory retriever. And here we need to initialize Alice memory. So we assign a username, which is Alice, and give Alice some attributes. Here you can assign age. Here Alice is 20 years old, and I give her some traits like adventurous, curious, and friendly, and status hungry. Just feel free to play with those. And then we add memory. And during this process, we can also do some safety check. So we can print out and make sure the memory is working. So we can ask Alice to summarize her memory. And here is what printed out. Okay, seems it works. So she knows she's a person who lives in College Park. And similarly, we create a second agent, which is called Bob. So we need a Bob's memory object. And Bob is 21 years old, is shy, humorous, and goofy, but similarly, he's also hungry. And then we add Bob's memory and do another round of sanity check, make sure Bob is right. And then we can store all those conversations and ask those two agents to have conversation. But like, how many conversations do we want? Because we don't want them to chat endlessly. It will cost you a lot for the API. And we also do not want them to chat just too short. We want to have meaningful answers. So here I set a number of turns, like 5 turns, and hopefully they can reach a launch decision within 5 turns. So now Alice and Bob start to chat with each other, and if the turn is fewer than 5 turns, they will continue the conversation. And sometimes, because large language models is like a black box, sometimes they just refuse to chat again. So you need to check if they are still in the conversation. If not, then we just return the results. Like, yeah. So here I print out if it's not here. I mean, if they did not reach the turn limits, but they still end the conversation, then I record this as the conversation ended by the agent, or conversation reached the turn limit. So if you run the code, you will see results like this: initial reply, next reply, next reply. And then we can introduce the third agent, which is an interview agent. So the interview agent does not need to have any memory, because the only role is to ask questions to check their conversation. So here the agent asks Alice, where are you going to have lunch with Bob? And then we record Alice's answer. And similarly, it checks Bob's memory. Cool. So this is the rough idea of the agent feature. I know there are a lot of code and it may look overwhelming, but I just want to show you that if you if you clone my repository, you can just treat this as a template, and you can revise the memory and add agents as you like. So you do not need to know all those mechanisms. Okay. So if you are interested, and after like you've taken some front-end classes, you can challenge yourself. Here are two exercise. Like the first one is to create more interesting agents. And since like two college parkers discuss lunch options, they do not add any productivity. So if you can create some like agents for you to debug your homework, to discuss exam questions, that might be helpful. And for the front end, so currently I just print out the ChatGPT's answer and I hard code the prompt. You can just add a submit button and an input box so that it fully recreates ChatGPT. And another one is that during those conversations, like when you use WhatsApp or messengers, we have profile pictures. So you can also add pictures for those two agents. Those are optional exercise. And so far, I've only covered OpenAI API. It's online and it costs some money. So, and also you share your data with OpenAI, although it has some privacy policies. But in case you really don't want to share your data with any other companies and you don't want to pay for the API, or you want to customize your large language models, in that case, you may want to run large language models locally. So how does that work? Because it's called large language models, it requires a lot of memory. So even for some small large language models, I think at least 8 GB RAM. So check your laptop, make sure you can run that on your laptop or it will freeze. So if you're on Mac or Linux, you can use the Ollama server and you download that and just serve. And then you can just replace the import OpenAI with import Ollama. Or if you're on Windows, you can check this website. It's called LM Studio. I believe Ollama will also have Windows version in the future, but not now. Okay. Yeah, so here are also some additional resources like the long chain document and how to use Llama 2. This Llama 2 is an open source model and is free. And another more advanced an AI agent work is like some researchers have created a software company purely by AI agents. So here I can show you. Okay, so the work is called ChatDave. So it's a virtual software company, and I believe they have 25 agents, and each agent has a different role. Like one is CEO, and one is like chief product officer, and some art designers, reviewers, testers. And then if you give them, if you give the company a task, like develop a game, then they will start to solve the task. So they will divide the task. Like designers will create mockups, and the programmers will write code. They will even debug by themselves. And they also tested the capability to write other games, and it turned out they are capable of writing a lot of games in several minutes with like $1 cost. So that's much cheaper than human developers. I think this is a very cool work, and make sure to check that. Okay, yeah, I attached the link here. I think Technica will share my slides with you, so you can check them later. Okay, yeah, so that would be the end of my talk. And any questions? No questions? Any questions on the Zoom? Okay, so if no questions, that's it. and enjoy your hacking process.